Hello everyone, I'm here to showcase my New York City bike analysis project. The datasets I'll be using is the bike routes from the city of New York and the borough boundaries of New York City. You can get the links right here and here. The bike routes comes in as a CSV and the boroughs comes in as a GeoJSON, which is what we want. Next is the constants and imports. So I'll be using quite a bit of imports, pandas, NumPy, matplotlib, networks for graphs, shapely for graphs, so things like that. The constants, so the metrics I'll be using for this is the EPSG 3857 metrics. It's a project coordinated system for web mapping application. Next to are links. This is where you control it. Then the next couple are grid sizes and base metrics we'll be using. Then we load the data. The bike groups come in as a CSV with geometry saved as either a WKT or a JSON string. So this function finds the right column, which right here, and converts it into a puppet shape using shapely right here. Then we turn it into a geo data frame and we project it into the metrics I talked about earlier, the EPSG one. I'm using the 3857, and then so it's easy. So this gives us all the bike segments and borough shapes ready to use. So we currently have 27,000 bike segments and 104 borough polygons. Next, here's some feature engineering. First, I calculated the length in kilometers, then extract the start and endpoints to compute the segment variance or direct angles. If the dataset includes lane info, right here. We flag which lanes are two-way, useful. Lastly, we build a graph of segment and endpoints using NetworkX to calculate node degrees, which tells us how connected each segment is. Higher values mean more intersections, while lower values often points to isolated or dead-end lanes. Here's the first few rows of these new columns. As you can see, the node degrees in two ways. This is just 5 first rows. Next are the charts. On the first chart shows most bike segments are really short, most of them being under 50 kilometers or 50 meters. The second chart shows that most lane follows a northeast projection, eastern projection, east to like south, well, northeast to south projection, I would say. The third chart shows about a third of the segments are poorly made, like here, or poorly connected, and again dead end or stubs. Here's a table I made. As I found out, Brooklyn has the most lane kilometers, but Manhattan is the most dense. Staten Island stands out as the most underserved, underfit right here, with the lowest coverage and fewest segments overall. Moving on to coverage, this is where those grids concept comes in. Any cells with less than 15% coverage are shown in red. In red, we don't really care about that. We only care about the islands. It's shown in red, as you can see. 86.8% of the city falls into that gap zone, especially Staten Island, Queens, and a lot part of Brooklyn. Manhattan has solid coverage, If you go back to that table, you would see, but it's the most dense. And yeah, heads up, but key corridors. But overall, most of the city still lacks proper access. But right here. Now let's figure out where to actually build. First, I made a basic ranking. Area and gap. Right here. Area and gap. Then add estimated traffic, AADT, using gamma right here, and cost per accumulator. Then ran a linear program that picks the best cell under a 30 million budget. The optimizer chose 63 cells, equating to about 25.2 kilometers. Total cost is under 30 million. And the rated score was at about 39,000, meaning we target high need, high use areas for maximum impact. Finally, I ran a Monte Carlo simulation to see how much these new lanes could shift bike ridership citywide. I ran it 1,000 times. Ran it 1,000 times right here, then over here. You can mess with that more, but to simulate noise, then measure how many extra grid cells got covered. Didn't turn out the best at a 0.01% points. You can see it better on this graph, but as expected, it's still measurable progress given that it's looking at a city ride, especially if you pair it with future expansion. If there's anything I messed up on or you think needs to be improved, please let me know down below. I shared the project link in the description of this project or this video. Thanks for watching. See you.